Hey guys, we are moving on to something called mean absolute deviation today. And basically what you're doing is you're finding the mean of a set of data, and then you're finding out how far each data point is away from the mean, okay? And when I was first looking at this, which I teach it every year, but this year I was kind of sitting at home and was like, well, what's really the purpose of this? And it's actually useful, especially in like the world of sports. For instance, basketball shooting averages, which is the example here, like basically this is a dot plot that shows how many baskets a player scored for like a whole season. Like some games they scored 2, some they scored 3, some they scored 6, 7, 8, 9, or 6, 7, 8. And then the other player scored closer together, like they scored mainly 4 points per game, or mainly 5, and then 1, 7. So when you're calculating a shooting average, you use mean absolute deviation, okay? So I'll go into that a little bit more in a second. So basically, again, the mean absolute deviation, or MAD, M-A-D, is the average distance each data point is from the mean. The steps are: 1, you find the mean. 2, you subtract each data point from the mean. And if the number is negative, you make it positive, okay? And then you find the mean of the numbers from step 2, okay? So let's get started here. So basically I need to find the mean first, okay? So for player 1, it's a dot plot, so I'm going to take the information from the dot plot. I've got 2 plus 2. Let's see here, I'm going to make this a little bit bigger. 2 plus 2 plus 3 plus 3 plus 3 plus 6 plus 6 plus 7 plus 7 plus 8. Okay? And that ends up being 47. It equals 47. Okay? I find the mean by dividing the sum by the number of data points there are. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So I take 47 and I divide by 10, and the mean is 4.7. Okay? Now, the next step is to subtract 4.7 from each data point. Okay? Because you're finding the distance numerically each point is from it. So that's exactly what I'm going to do. I'm going to take each data point. So I'll do 2 minus 4.7. Okay, and that is going to be negative 2.7. Okay, then I do minus 4.7 again, and it's negative 2.7. Okay, minus 4.7 is going to be negative 1.7. Then minus 4.7 again is negative 1.7. It's going to be the same here. I'm just going to draw a line, negative 1.7. Okay? And then 6 minus that is going to be 1.3. It's positive. So minus 4.7 is going to be 1.3. And 1.3 again. And 7 minus 4.7 is going to be 2.3. And then 2.3 again, because it's 7. And 8 minus 4.7 is 3.3. Sorry, it's a little hard to see here. Let me erase that. Is 3.3. Okay, now I'm going to take the mean of this set of data, what I've subtracted. But before I can do that, I want to make sure everything's positive, okay? So I will, instead of negative 2.7, it will be 2.7, okay? Then I'll take 2.7 plus 2.7, etc., okay? But I'm not going to write all that down. I'm just going to erase the negative sign here, okay? And then I'm going to add them all together. Sorry about the squeakiness. It wasn't squeaking before, but today it just started squeaking. I'll try to mess with it later. So now, hopefully you can see this. I add all of these together, and I find the average, or the mean, again. So I do 2.7 plus 2.7, plus 1.7 plus 1.7 plus 1.7 plus 1.3 plus 1.3 plus 2.3 plus 2.3 plus 3.3. Okay, and it ends up being 21. Okay, then I'm finding the mean again. I still have 10 numbers, so I'm going to divide that by 10. And so the mean absolute deviation, or the MAD, is 2.1. Okay? Or that is also this person's shooting average. Okay? Or the deviation of how much they, or not the shooting average, but it shows how far each data point is from the mean. Okay? Now, player 2, we're going to do the same thing. Okay? I'm going to find the mean. Again, I picked 2 sets of data with that would have the same mean, and it is, again, 4.7. Okay? So I'm going to take, again, the mean and subtract it from each data point. Okay? So, for instance, just squat down here. I'm going to do, I've got 4 is one data point, minus 4.7. Then I have 4 minus 4.7, and then 4 minus 4.7, and then 2 more 4s, minus 4.7 minus 4.7. Each of these end up being negative 0.3, negative 0.3, negative, okay? Now, 5 minus 4.7 is going to be, wait, I think I did that wrong. 4 minus 4, I'm sorry, it's not, see, I'm making mistakes. 4 minus 4.7 is negative 0.7. I got that confused. Whoops. So change that, my bad. Okay, now, 5 minus 4.7, if I can draw, is going to be negative 0.3. Okay, there we go. That's right. And then there's 4 5s. So I'm just going to arrow down negative 0.3, 0.3, negative 0.3, and then 7 minus 4.7 is 2.3. And then 7, so 2.3. Okay, so now what I need to do is I need to find the average of these numbers again. Oh, but wait, we have to make sure these are all positive. So I'm just going to go along and erase the negative signs if there are there. Now I can find the average. So I'm going to again add all of these together. Add 0.7 plus 0.7 plus 0.7 plus 0.7 plus 0.7 plus 0.3 plus 0.3 plus 0.3 plus 0.3 plus 2.3. Okay, and there I end up with 9.7. Okay. Now again, there are 10 values, so I divide by 10, and my answer is a decimal. It is the MAD, mean absolute deviation, is, or how far each thing, the average of how far each data point varies from the mean is 0.97. Okay? Now here's why this is relevant with shooting scores, with shooting averages. If I look at this player and I look at their points per game, or their baskets per game, they're kind of all over the place. Some games they have good games. They score like 8 or 7 baskets, or even 6. Some are not so great, 2 or like 3. Now player 2 though, player 2 is a lot more consistent, which is what you want. You want a player that's going to be consistent and score about the same number of points, kind of regardless of what game it is. So they have the same mean, which is 4.7, okay? So there's that and that, but they have their spread is much different. That's what spread means, is how the data points are spread out, okay? Much narrow spread, and this spread's much wider. So you have mainly 4 baskets and 5 baskets, and then 1 7, okay? So the mean absolute deviation here is very small. It's less than 1. It's 0.97, whereas the mean absolute deviation here is 2.1, okay? So they were looking for a player that is more consistent. Obviously, player 2 is more consistent because they have a smaller mean absolute deviation, okay? Hopefully you can read this. I took a picture of the notes too, and I have uploaded that along with the video so that you can will help you take notes from this. So go aheget and get your notes and do your assignment. That's all, guys.